In this lecture, we are going to continue with liquid phase adsorption. We are going to perform some design calculation. So this is going to be slightly tricky. You have to pay some extra attention because we are going to deal with some graphical method that allows you to exploit the equilibrium data that we can get from the simple experiments, even from a laboratory scale experiments. So in the last lecture, I talked how to perform a liquid phase adsorption experiment, and then we get CE. So we know our initial concentration from that, and from the experiment we know how to get CE. CE is referred to as you can call it as equilibrium concentration. So this is something like you perform the adsorption experiment and then you monitor your C naught versus time, and then at some stage it comes to an equilibrium, and whatever the concentration that you see here, that's CE, grams per liter. If C naught is expressed in grams per liter, CE will be expressed in grams per liter. From that we can calculate QE value. I'm not explaining this in detail because I know you already learned this in physical chemistry modules. So you know what is an equilibrium concentration, and from that how to get your QE value. So it's really an easy experiment. All you need is to take a vial or take some reactor, put your solution, and you must know the initial concentration of the solution, say C0 grams per liter. Add your adsorbent. You need to know the mass of your adsorbent, say expressed in terms of grams, and then you provide agitation, and then you monitor the kinetics, something like this, which is shown in this graph. And then from there you can know when you reach the equilibrium. Say you reached equilibrium, say at like time equal to 2 hours, and whatever the concentration that you measure at that particular instant of time, that's nothing but your CE, grams per liter. So you can repeat this experiment starting from different initial concentration, and then you can measure the CE value. From there you will get your QE value. I said QE is nothing but amount adsorbed per unit mass of adsorbent. I'm sure you know what is this because you must have studied this in physical chemistry course, but I'm not sure whether you know the reason why we express QE in terms of say like grams of solute adsorbed per gram of adsorbent. Yeah. So QE, if you want, you can also express in terms of milligrams of solute adsorbed per gram of adsorbent. And QE we calculate. It's okay to go this part of the lecture bit slow. C0 minus CE V by M. I said to you in the previous lecture, we can just express the amount adsorbed is equal to C0 minus CE. That will be some number that will be expressed in terms of grams per liter. Say if C0 is 100 grams per liter, if your CE is 50 grams per liter. So whatever the difference will be 50 grams per liter. So that's the amount adsorbed onto the solid. This is completely okay to express the amount adsorbed onto the solid in terms of 50 grams per liter, but still we converted this into grams per gram, so 50 grams per liter. So we did this C0 minus CE multiplied by V by M. Yeah. So say like if this experiment we performed in say like 2 liters, and then say the mass we used say like 5 grams. So the QE value will be 50 grams per liter multiplied by 2 liters divided by 5 grams. So liter get cancelled. So it will be equal to 50 multiplied by 2, that will be 100 gram. Oh sorry, you have 5 gram here, so 5, 5, 10. So that will be equal to 20 gram of your solute adsorbed per gram of, let me write it in the next page. So QE will be 20 gram of solute adsorbed per gram of adsorbent. So this QE value, we have this quantity, something called as V by M. So why do we need this parameter V by M in QE? Because it helps to calculate a lot of things. So that's what we are going to learn in this lecture. So let's assume we did the equilibrium experiment. So I hope yesterday I showed you something like a butyric acid adsorption by activated carbon. So let's repeat the same process. So let's call, say, problem 1. So let's say we need to remove butyric acid from fermentation broth. This video might be a bit lengthy because it's going to be, there are some tricky procedures involved. From fermentation broth using activated carbon as adsorbent, So let's assume we performed equilibrium experiment. So adsorption equilibrium experiment is nothing but whatever I explained in the previous lectures. So it's just contacting your solid and solution that contains your solute until it reaches an equilibrium. So, and at the end of the experiment, you check what's the concentration of the solute in the solution, and that will be your CE, and you know your C0, your initial concentration. From that, you know how to calculate QE. You know the volume of solution, mass of adsorbent we added. So that's nothing but an adsorption equilibrium experiment. So let's say that we performed an adsorption equilibrium experiment starting with the different initial concentrations, starting with solution of different initial concentration. Yeah? So I'm going to show what are the experimental conditions. So we did how many experiments? Let's say 1, 2, 3, 4, 5, 6, 7, 8. Let's say we started our experiment with 8 different reactor. Say like we have 8 different small reactors. 1, 2, 3, 4, 5, 6, 7, 8. And then we add 25 ml of solution for fermentation broth. But in each vial our initial concentration is going to be different. So in the first vial our initial concentration will be 0.1. So C0 is expressed in terms of grams per liter. 0.1, and then 2, 5, 10, 20, 30, 40 and 50, and then we have CE expressed in terms of grams per liter. 0.02, 0.3, 2.21, 6.2, 15.3, 25.19, 34.83, 44.27. So from this we can calculate QE, which is nothing but C0 minus CE multiplied by V by M. So always pay attention to the units. Say like if your concentration is expressed in terms of grams per liter, then V must be expressed in terms of liter, and mass, it can be any gravimetric units, it can be grams. So I prefer to use mass, I prefer to express mass in terms of grams. So how to calculate this one? See, 0.1 minus 0.02 multiplied by our volume of solution is I had some issues with my tab, it crashed. So let me continue. 0.1 minus 0.02 multiplied by 0.25, and then you substitute mass here. Mass in this case is how many grams? Let me check. Say 0.5 grams. So I'm just going to summarize here. So we are doing some eight experiments, and we are having some solution of different initial concentration in each of these reactor, and our volume of the solution is 25 ml, or if you want we can call volume of reactor is 25 ml. It's a very small volume, and then we are adding an adsorbent of mass 0.5 grams, 5 grams in each of these reactor, and then we wait until the system reaches an equilibrium. And once the system reached an equilibrium, so these are the equilibrium concentration values. So 0.02, 0.3, 2.25, 6.2, 6.2. So I will just put an arrow. So if you start from 0.1 grams per liter, at equilibrium concentration is 0.02 grams per liter, and if you go to 50 grams per liter, this is your initial concentration, and you reach equilibrium when your solution concentration is 44.27 grams per liter. So from this we can calculate our QE values. So let me go to the next page, make it a bit clear. C0 and CE are expressed in terms of grams per liter. QE is C0 CeV by m expressed in terms of grams per gram. I already calculated the values, so I will write it for you. 50, and then sorry for going a bit slow. This is it's not a tough calculation, but you have to use a bit of your graph sheets, or if you want you can use also Excel. So there are few tricks to do this, and I'm going to go slow because you won't find this type of problem in some normal textbook, say like physical chemistry or so on. So it's okay to learn this bit slow. So our QE values will be 0.85.1395.19, 0.235, 0.2405, so 0.2585, and then 0.2865. So if you plot these values, you will get let's try to plot on this normal sheet. So let's put 0 here. You have equilibrium concentration on the x-axis, and the amount adsorbed expressed in terms of gram of solute adsorbed per gram of your adsorbent is on the y-axis. So let's put something like 0.05, 0.1, 0.15, 0.2, 0.25, 0.3, let's say 10, 20, 30, 40, and 50. So let's plot one by one. So let's take these two values. C is 0.02 and amount adsorbed is 0.004. So that's almost near your origin. It will be somewhere around here. It will be around here, near 0. And then your next value is 0.3 C is 0.3 and Q will be 0.085, so that will be somewhere around here. And then the third value is 2.21 and 0.1395, so it will be somewhere around here. And then 6.2, and then 0.19, it will be around here. And then 15.3 is 0.235, somewhere around here. Try to plot yourself in the, take a graph sheet and try to use these values, or if you want you can even calculate QE values using calculator or an Excel sheet and try to calculate. And then this one 25.19, and that's 0.245, so that will be somewhere around here. And then 34.83, that's 0.2585, around here. And then 44.27, that's 0.2865. It will be somewhere around here. So if you connect them, you will get some curve like this. Try to plot on your graph paper. So this is such a simple diagram. I'm sure you must have learned this in physical chemistry module. And I know if you want, we can even apply a Langmuir isotherm, and then we can calculate the Langmuir isotherm parameters. But for this module, I'm going to show you, like, if you look at this QU value, we expressed in terms of V by M. We added a parameter V by M, and that makes our life a bit easy. So we are going to exploit this plot. So in order to, so whatever the experimental data you have here, so these are performed starting from different initial concentration, see, and then we used a adsorbent mass of just 0.5 grams, yeah, and then we used a volume of 0.025 milliliter, 0.025 milliliters, liters, 0.025 liters. And then just with this ratio, so V by M will be equal to 0.025 divided by 0.5, so that should be equal to what's the number? It should be equal to 0.05 liters per gram. So this is only one condition. So we started from an experiment, 8 experiments with solution of different initial concentration, and then but fixed volume and fixed mass. So if I ask you to tell me what will be the, say, like, you start an experiment, say like 50 grams per liter, and say volume, let's fix the volume 0.025 liters, and this time instead of 0.5 grams I'm going to add 1 gram. So what will be the CE value? So for this we don't have to do the experiment starting from the scratch, like take a reactor, add 25 ml of solution whose initial concentration will be equal to 50 grams per liter, and then you add say like 1 gram of your adsorbent, wait for say another 24 hours. If the equilibrium time is 24 hours, then you have to wait 1 more day to get your CU value. But in fact you don't have to do that. That is, we have some graphical method that will allows you to calculate what will be the CE if you change your mass. Or if just imagine if you do another experiment, say like you start with the initial concentration of 50 grams per liter, and let's fix the mass. Say like we are using 0.5 gram of adsorbent, but this time we are using a volume of say 0.05 liter, so something like a 50 ml of your solution. So in this type of experiment, what will be your CE value? So how to get this value? So we can get all this value just from this one single equilibrium curve, and using a graphical method. And if this graphical method should work, then it is a must that you express your QE value using this formula, V by m, C0 minus CE into V by m. So before going into before trying to solve this type of problems using the graphical method, let's do some mass balance calculations. Yeah? So let's do a simple mass balance. So mass balance is something like whatever that stays inside the reactor, it will not disappear. Yeah. So if you add 1 gram of something, say like a reactant A, if you add 2 gram of say reactant B, and you just close the reactor and you agitate the system, for 24 hours or 24 years. If nothing evaporates out of this reactor, you will not lose the mass. At the end of the day, the mass inside the reactor will be say 3 grams. So mass will be conserved. So that's the principle, or if you want you can call law of conservation of mass. So with this knowledge, let's do the mass balance. So I said to you how we performed an experiment. So what we are going to do now is like so let's call this as our adsorption system, or you can call us adsorber. So what we are going to do at time t is equal to 0, we need to calculate the mass of solute in the liquid side and mass of solute on the solid side. Yeah. So let's express the mass in terms of in terms of grams. So what we need is like we need to know grams of solute. So we know adsorption is like you pass a solution that contains your solute, and then you adsorb them using a solid material. So at time t equal to 0, you have to tell me grams of solute in the liquid phase and grams of solute in the solid phase. It's going to take a bit of time to solve this problem. So it's very simple. So if we know the initial concentration is expressed in terms of grams per liter, we just multiply it by the reactor volume. That should be equal to grams per liter multiplied by liter. So what is this? This is a gram of solute by liter of solvent. This is this liter. This is the reactor volume. Or if you want, you can even call it as a volume of the solvent. So what is this? So liter get cancelled. So your C0 will be grams of solute. So this is the concentration of your solute when time t equal to 0, but expressed in terms of grams. So let's call grams of solute when time t equal to 0 will be equal to C0 multiplied by V, and then grams of solute in the solid side. So we know QE is expressed in terms of grams of solute multiplied divided by gram of adsorbent. You just multiplied by the mass of adsorbent that you added. So M is also expressed in grams of adsorbent. So this and this value get cancelled. So QE, then the gram of solute in the solid side will be equal to QE multiplied by M, where QE is the amount adsorbed. I hope you all can follow this one. Per unit mass of adsorbent multiplied by M is nothing but the mass of the adsorbent added in that say like a 25 ml of your solution. So this is the condition at time t equal to 0, and let's assume that we already finished our equilibrium experiment and we reached the time equilibrium time, and now you can calculate the grams of solute in the liquid side and the grams of solute in the solid side. So at equilibrium your solid will contain lot of solute particles attached, and then you will also have some solute particles in the solution which is in equilibrium with each other. So you need to calculate how much solute is adsorbed to the solid side and what's the mass of solute in the liquid side. So this is in grams, this is in grams. So this is same. So grams of solute in the liquid side must be equal to, when time t equal to equilibrium time, your C will be equal to CE, which is equilibrium concentration. So CE, which is expressed in terms of grams per liter, you just multiplied by volume. Volume is expressed in liter, so volume of your reactor or volume of your solution. So liter and liter will get cancelled. So CE will be, so you will get something in terms of grams. So whatever the value you get, that will be the grams of solute in the liquid side. So how do you get the grams of solute on the solid side? So we know at equilibrium the solid concentration will be equal to QE Okay, let's go back. I think I have to use another notations. If we come back here, we have this gram of solute in the solid side when time t equal to 0. Let's use a notation Q0. Q0 refers to gram of solute adsorbed onto per gram of adsorbent. And then we are going to multiply this quantity by M. So this will be Q0 multiplied by M. So the amount, so the, how do you call, the grams of solute in the solid side when time t equal to 0 is Q0 multiplied by M. I hope you all can follow this one. So come back to here. So gram of solute on the solid side at equilibrium should be equal to QE multiplied by the mass of adsorbent. So QE is expressed in terms of gram of solute divided by gram of adsorbent multiplied by gram of adsorbent. So G and G get cancelled. So you will get something in terms of gram of solute on the solid side. So we are performing this experiment in batch mode. So what we did is like you add something at time t equal to 0. So we can perform the like a mass balance, say like the grams of solute in liquids plus gram of solute in the solid side at time t equal to 0. That should be equal to, this should be equal to gram of solute in liquid plus gram of solute in the solid when time t is equal to equilibrium time. So why is that? Because we know that we cannot destroy the mass. So whatever the mass that goes inside the reactor, it's going to stay inside because nothing is going to get evaporated or vaporized, whatever. So if you started with say like 3 grams in total, even at equilibrium you will have 3 gram of mass inside. Yeah, the only difference is like the concentration of in solid may be higher at equilibrium concentration. So whereas the concentration of solute in the solid will be 0 when time t is equal to 0. Time t equal to 0. Sorry. So we can substitute the formula whatever we know so far. So we know gram of solute in the liquid is C0 multiplied by V. Gram of solute in the solid side when time t equal to 0 is Q0 multiplied by M. And we know gram of solute in the liquid at equilibrium is C E multiplied by V. And we know the gram of solute in the solid side at equilibrium will be equal to QE multiplied by M. So let's write it. C0V plus Q0M should be equal to CEV plus QEM. So this should balance each other because whatever the mass that goes in, that should remain in the solution, that should remain in the reactor. Yeah. So because mass is always conserved. So I hope up to this everything is fine. So just to pay attention to the units, this derivation part is going to be really simple. So I'm going to restructure this expression. So I'm going to take all the Q values on one side, all the concentration on the other side. So what do I mean by that? So let's take the solution concentration to the one side of the equation. So let's say C0V minus CEV should be equal to QEM minus Q0M. So C0 minus CE, we take V is a common factor, and here M is a common factor, QE minus Q0. So what to do now? QE minus Q0. I think I'm not doing any mistake. Q0 minus QE into M So let's take this one C0. Yes. So QE minus Q0 is equal to V by M into C0 minus CE, or you can multiply by minus on both sides. So multiply by minus on both sides. Then Q0 equal to minus V by M C0 minus CE, or Q0 minus QE is equal to minus V by M C0 minus CE. So what we have in this relation is something like we are relating something like whatever that happens at time t equal to 0. Let me write it here. So what this expression, we have Q0, that's your solid concentration when time t equal to 0, and then QE is your solid concentration when we reached equilibrium. So let's say equilibrium or at equilibrium, again solid concentration. And then we have the liquid concentration of your solute in the liquid side when t is equal to 0 in the liquid side, and then this is when time at equilibrium the concentration of solute in the liquid side. So this is liquid, and then we have a parameter that talks about your reactor volume, and then mass, your adsorbent mass. So this equation is such a simple expression, but it will solve a lot of problem. Yeah, so what this expression says, say like so let me write again here, Q0 minus QE. You must pay attention to this part. This is the bit tough part, because I know you all know how to deal with y is equal to mx plus c. Say like you have x value here, you have y value here, you get some linear line, your slope will be equal to m and your intercept will be equal to c. So but this is slightly a different type of equation. So what it says is like so if we have a plot, let me change the color, just follow the highlighter. So this is the expression we have, and you have QE, and then you have CE, and then you have V by M multiplied to this parameter C0 minus CE. If you have any expression like that, and if you plot this value on the y-axis and then this value on the x-axis, so let me change to pen. Say your x-axis is CE expressed in grams per liter, y-axis is QE expressed in grams per liter, and then this is our equilibrium data. We did some experiment at a fixed V by M ratio. So in this case our V by M ratio is 0.025 divided by 0.5, so that should be equal to let me calculate it. It should be equal to 0.05. So this is obtained at a constant V by M ratio of 0.05. Keep this in your mind. So according to this expression, so just to follow this highlighter. So just according to this expression, say like so once you plotted Q0 and QE on the y-axis and C on the x-axis, say pick a point here. Yep. Okay, let me change the color. Follow the pink colored pen. Yeah, this is going to be really tricky. So pick a point here. So let's call this our C0 value. So let's assume we are going to do some experiment of some initial concentration. Say, okay, let's put 0, 10, 20, 30, 40, and this point is 50. Say, put a point here and let's call it as a C0 point, 50 grams per liter. And if you perform an experiment and then with some particular volume and some particular mass, and then if you get a CE value, say it is somewhere around here. So this point is your CE value that you obtain from this experiment. If you connect these 2 points, that slope value will be equal to minus V by M. That slope value will be equal to minus V by M. So if you come down, if you put a line down, so this will be your CE value if you started your experiment at 50 grams per liter. And then if you draw a line here, so that will be your QE value, amount adsorbed. So this is bit tricky. So that's the meaning of this expression. So if the above expression is true, the line that connects C0 with CE, the slope of that line should be equal to V minus M, and the point where this line, where the line that connects C0 and CE, it should cut your curve at a point, and that the corresponding y-axis value should give your Q0 value. So let me do it again one more time because it's going to be very tricky. So this is not an easy topic. Probably that's why you are not seeing this in many textbooks. C is expressed in grams per liter, Q is expressed in grams per liter, grams per gram. So let's write this equation again. Q0 minus QE equal to minus V by M C0 minus CE. So what we are doing now is like take these 2 values Q0 and C0. So we plot Q0, or we locate a point C0 comma Q0. So what is this? So let me rewrite again here. If we need to find or determine the amount adsorbed for some set of experimental conditions, from some set of experimental conditions, say your C0, say like 50 grams per liter, and then say your volume, say is like 0.5, say like say 0.05 liter, say your mass is equal to 0.5 grams for example. So all you need to do is like you plot CE grams per liter, QE grams per gram, you get your equilibrium curve. So this is the data which I will give in the exam if I ask this question. So I give the equilibrium data, so you plot QE versus CE, and then if I ask you like what will be the amount that we are going to adsorb if I start the experiment with a solution of 50 grams per liter, and the volume of our solution is 0.05 liter, and then our mass is 0.5 grams. Yeah. So all you need to do is like say locate the point C0 comma Q0. So Q0 will be always 0 because when time t equal to 0 nothing will be absorbed. So your QE value QE will be equal to Q0 on this line on the x-axis. So C says like C0 is 50 grams per liter, QE will be equal to 0 grams per gram. So that will be say like 5, 10, 15, 20, 25, 30, somewhere 40, 50. So that point will be here. So this is your C0 comma Q0 point. It's very tricky. And then if I give you the value of V by M, take the ratio of V by M. So that will be equal to 0.05 divided by 0.5. So what's that value? That's equal to 0.1. So take the negative value. So minus V by M will be equal to minus 0.05 minus 0.1. So draw a line whose slope should be equal to 0.1. So you start from point this your C0 comma Q0 value and draw a line whose slope is equal to 0.1, and wherever this line intersects at your equilibrium curve, just so that will give the your corresponding CE value. So come down. So this is your CE value, and if you go back to your y-axis, so that one will give your QE value. So this is the graphical method that you should use. And imagine if I change the volume, say volume to say if you are doing the same experiment, say this is experiment 2, doing the same experiment C0 50 grams per liter, but this time you are performing the experiment in say like say 0.1 liters. That's our volume, and mass is equal to 0.5 grams. So what will be this? Then again you have to take the slope value minus V by M, that should be equal to minus 0.1 by 0.5. So that will be equal to minus 0.2. So what you need to do now is like again now follow the highlighter. So locate this point C0 Q0 and then draw a line whose slope should be equal to minus V by M, which is equal to minus 0.2, and whatever on the point where this slope intersect at your equilibrium curve, just that should give some information about your equilibrium concentration CE, and the corresponding Y value should give QE expressed in terms of grams per grams. So that's the graphical method. And if you come back to this equation, this is what the equation states. So if you plot C0 and QE, or if you connect C0 and QE, and if you connect the point CE and QE, how do you say like let me go back to the next page, so that might make your life a bit easy. This is very tricky. This is very very tough. You should practice yourself. If not, you will be in trouble. So what this expression says, this type of equation, what it says is, my God, let me change just follow the whatever I'm writing now. So what this equation says is like this is our slope value. So just follow the pink one, C0 and Q0. C0 comma Q0, and then you identify this point, and then you identify this point CE and QE, CE comma QE. So you have an equilibrium curve, CE versus QE. CE is expressed in grams per liter, QE is expressed in grams per gram. So let's say like we identified C0 comma Q0, that's point somewhere here, C0 comma Q0, and then let's identify CE comma QE, which is here. And if you connect these 2 points, that slope will be equal to minus V by M, so which is in this equation here. So that's the meaning of that expression. So if you want, we can test that, say like so I hope you all understand up to this point. So if this case is true, so in this case, like what we are doing now is like imagine you have some experimental data, we plot CE, we have QE, we plotted everything, and then from the experimental data we can easily say, like, even if you take the problem which we solved, if we go back to the problem that we solved now, where is that? Couldn't find it. If we come back to this problem, say here, I think I solved it in the next page. So you just take this value alone, the last value. So you start with a C0 of 50 grams per liter, and then our corresponding equilibrium concentration is 44.27, and then the corresponding QE value is 0.2865. Yeah, so let's take this value. So we know C0 is 50 grams per liter, CE is 44.27, and then QE is 0.2865, and we did the experiment with volume 0.025 liters and mass is equal to 0.5 grams. Yeah. So what we are going to do is like we are going to plot C0 comma Q0 and CE comma QE. So C0 comma Q0 is nothing but 50 comma 0. Say this is somewhere around here, 50 comma 0. 0 means nothing is adsorbed. So 0 amount of solute is adsorbed onto your adsorbent. So this is, follow the blue line. So this point is 50 comma 0, and then we can add, we already have CE comma QE, which is equal to 44.27 comma 0.2865. So let's say that points lie somewhere around here. So CE is 44.27 and QE is somewhere around, say this value is 0.2865. So this point, they intersect at the equilibrium curve at this point, 44.27 comma 0.2865. If you connect these 2 points, this slope will be automatically equal to minus V by M, which should be equal to minus 0.025 divided by 0.5. So that's the meaning of this expression. Write the expression Q0 C0 minus CE. So in this case we have everything. We have our C0 value, we know our Q0 value, we know what is our CE value, and we know what is our QE value, and we also know what is our slope value. Yeah? So but what I will ask in the exam, or what I mean by like performing a design calculation, is like I'm going to give you just the initial concentration, and then you have to tell me, and I will tell you the volume of the solution that we are going to deal with, and then the mass of the adsorbent that we are going to deal with. And from that you have to tell to me what will be the equilibrium concentration. Yeah. So what's the purpose of doing this graphical method? Say like we did this we did the removal of butyric acid from fermentation broth in a simple lab scale reactor. We just used 25 ml of our solution. Okay, and now we have to deal with really an industrial scale problem. Say like this time we are dealing with say 1000 liters of a fermentation broth, and then let's say the initial concentration is say like 20 grams per liter, and then the mass of adsorbent say like how many kilograms? Let's say like say for example 20 kilograms. It will be equal to 20,000 grams. And if I ask you, and you have the equilibrium data CE versus QE, which is obtained just with the 25 ml reactor, but you have a very beautiful curve CE versus QE, and if I ask you to calculate what will be the CE in the industrial scale reactor, you can calculate, you can get that value without performing an experiment in a large scale reactor. So all we need to do is like we know the volume is equal to 1000 liters, and then we know the mass is equal to 20,000 grams. So take the negative value of minus V by M, that should be equal to 1000 by minus 20,000. So that will be equal to minus 0.05. So what you need to do is like you have to generate a line. So we know the C0 value is 20 grams per liter. So let's assume this is our C0 say 20 grams per liter. And then you have to draw a line starting from this point, and the slope of this line should be equal to minus 0.05. So if you manage to draw this line with this particular specific slope value, then we can get wherever this line, we call this as operating line. I forgot to mention, we call this as operating line in adsorption. So from this point we can get our CE value, and from the corresponding y-axis we can get the amount adsorbed QE. So that's how we calculate, and that's the benefit of I know that in physical chemistry lab and also in your theory you might have done all these experiments, adsorption of some compound, and probably you might even generated this CE versus QE curve. You might got this some type of curve, but in chemical engineering we exploit this type of simple curve that anyone can obtain in the lab, and in order to get some information, especially if you're going to deal with a really a large scale reactor. So it's not a tough job to do. Like so we use just only this simple curve, say like 10, 20, 30, 40 and 50. And if I say my initial concentration is 40 grams per liter, all you need is to locate the point where your 40 grams per liter is. So and then you have, and I say like a volume and mass, from that you get the slope value minus V by m. So this is, you should draw the line whose slope should be equal to minus V by m, and wherever this operating line intersects on your equilibrium curve, from that point you can the corresponding x value of that point should give the CE value, and then the corresponding y value of that particular point, say let's call point P, the corresponding value of point P should give QE. So which means you can determine CE, we can determine QE. And if you want to calculate even the percentage, that you can, like a percentage, oh okay, for the moment leave it, then it will get confused. Just stick to this whatever I talked. So that's the graphical procedure that we need. I think this is enough, I think. And another advantage of this graphical technique is like say like you have only one equilibrium curve, and that you obtained that with a particular volume and particular mass, and you get some equilibrium curve. But with that one equilibrium curve, you can calculate the amount adsorbed. No matter you start from say like 10 grams per liter, and then volume of say 50 ml, mass of 0.5 grams, or say you do another experiment, C0 of 20 grams per liter, volume is 100 ml, mass is 0.5 gram. You see another experiment, C0 of 30 grams per liter, say this time volume we used only 25 ml, but we used a mass of 0.1 gram. So no matter, irrespective of these conditions, still you can calculate for each of this experiment what will be the amount adsorbed at equilibrium, what will be the equilibrium concentration at equilibrium, and what will be the amount adsorbed at equilibrium. CE comma QE value, CE comma QE value. It's very easy. All you need is to draw the equilibrium curve, identify the C0 point, draw the slope line or operating line, and then from the particular point where your operating line intersects your equilibrium curve, from that point you can calculate your corresponding CE and QE values. So I hope you all can follow this one. It's so that's the graphical procedure that you are going to use to solve some problems. So I will stop recording. Try to listen to this few times, because it's not easy. I know that it's not easy, but you have to learn something new. Yeah? Because adsorption is a widely used technique, and adsorption equilibrium experiments are so easy to perform, and this graphical technique will save your life, especially if you don't know anything, like all you have is some equilibrium data, and if you want to predict the experimental outcome of some set of experimental conditions, say like if somebody say to you like I want to adsorb protein, and from an industrial scale reactor, and I at the moment I am dealing with say like 2000 liters of solution that contains my protein, and they say like I can add say like this many gram of some adsorbent. From that if they ask you to calculate, if I start my experiment with 20 grams per liter, so how much I can adsorb, or how much of protein I can adsorb from that solution at equilibrium time. So you can easily calculate using this graphical technique. So you shouldn't be scared. If you know this technique, then you don't have to worry about the volume of the reactor that you are going to deal with. If you perform adsorption experiment in 25 ml, or if you perform adsorption experiment in 25,000 liters, if you know the graphical technique, then, and if you have the equilibrium data in your hand, then you will know how to draw the slope line, how to locate your C0 point on the plot of CE versus QE, and then you just draw the slope line, and wherever the slope line intersects your equilibrium curve, from there you will know what is your CE value and what's your QE value. So I hope I explained this a bit okay. This is a really tough one. I know many students, they do mistake, and some of you must be already thinking how to get this line with this particular slope minus V by M. It's not a tough one. I will explain you maybe using a Excel sheet